Welcome to Module 1 of the IPv6 MIBs seminar from Interworking Labs. In this one, we will be discussing some of the background for IPv6 itself. IPv6, the documents are listed in the following two slides. The first slide are the normative references. These are the ones that describe the actual workings of the protocol and must be adhered to. The second set are some extra information that describes useful things to go along with the protocol, but for our particular purposes, they are not normative. For the MIBs themselves, the first ones are the controlling authorities, and the others just provide additional information. IPv6 is a response to a problem discovered in roughly 1992, where we were starting to run out of IPv4 addresses. 2 to the 32 does not really provide quite enough addresses for a completely global network. If you think about the number of people in the world, there's just not quite enough. So IPv6 went to a much larger address scheme, providing 2 to the 128th. It also took this opportunity to add other things that had been looked into for IPv4 and either added as a section on the side or were not quite there, and they were brought into the main protocol. These include things such as local and global addresses, so that you could have one address that had only a local scope and would be restricted to one area, and global addresses that would cover the entire network. It also added the security option at the IP layer. This is something that had been worked out in IPv4, but was actually included as a requirement in IPv6. Auto configuration, where you can just plug in a box into the network, and it will pick up much of its information from the network itself, in particular from router announcements, and then be able to operate. This doesn't work for all possible combinations of things, but it does work for relatively simple stuff. You could plug, say, a printer into your network, and it would be able to be on the network and start working. Other systems learning of the printer might require some other effort, but the printer itself would be able to interoperate. It also switched to using multicast instead of broadcast for many things. This will provide a much better performance on the network where you don't have broadcast storms. Instead of one system trying to find another and interfering with everybody, it will be able to multicast and limit the amount of traffic on the network. And lastly, there's neighbor discovery, which is been referred to as ARP on steroids. This allows one system to learn about another, to translate a IP address into a MAC address. It includes some other stuff in terms of figuring out duplicate addresses, and is a somewhat more robust version than ARP actually was. This concludes Module 1.